Hello and welcome to Math Blossoms, where growing in mathematics is natural. Let's get prepared for today's lesson on integers, adding and subtracting. Okay, our first word is, our first thing that we need is a pencil and preferably with an eraser. Also some paper to take notes. And then a calculator is optional, as well as the double-sided math chips. I will explain those in just a few minutes. Math chips are not required, but it is useful when you're learning how to do operations with integers. Don't forget to pause the video from time to time to answer the practice questions. That is the best way to learn, is to pause, try to answer the question on your own, and then look at the answer to compare to see if you get it right. Also, rewind the video if you need to review anything before you answer the questions. Okay, so before we start talking about our vocabulary words, allow me to introduce myself. I'm Miss G, the teacher, and before we get started on today's lesson, we need to clear our mind of everything that might be getting in the way of our learning. So let's go ahead and take 3 deep breaths. We're going to hold it in for a count of 3 and then breathe out. So breathe in the nose, hold it for 3, and then breathe out your mouth. Okay, let's start. 1, 2, 3. Let's breathe out our mouth. Okay, breath number 2. 1, 2, 3. Breathe out your mouth. Okay, one more time. Breathe in your nose. 1, 2, 3. Then breathe out your mouth. And if you need to breathe additional breaths before we get started, go ahead and do so, or pause from time to time to refocus yourself if you get distracted by anything. All right, let's look at some of these vocabulary terms. The first word is integer. An integer is all of our whole numbers, positive and negative, that do not, and also 0. 0 is neither positive nor negative. So again, it's all the whole numbers, including 0, positive and negative. Our next word is a positive sign and negative sign. So the signs on positive numbers is a plus, but we usually do not write the plus because if the negative symbol is not present, then it is an understood positive number. So most of your numbers that you work with, your natural numbers, they're always positive, even though we don't write the little positive symbol next to it. But if you want to write the symbol, you can. Okay, and then the negative sign, of course, is the minus symbol in front of the number, as you see in the integer number line here. Okay, and then opposites are basically the same number, but one is positive and one is negative. So like, for instance, this positive 2 here and this negative 2 are opposite numbers. So again, they're the same number, but one is positive and one is negative. When we add opposite numbers together, they always make a 0. Additive inverse is another name for adding opposites together. So if we add 2 numbers and it creates a 0, it essentially cancels each other out, and that's called an additive inverse. A number line is pictured here in front of you, and number lines are used frequently when we're working with integers because it shows how the positive numbers increase as you move to the right and the negative numbers increase as you move to the left. So the more negative a number is, the smaller the number is. The more left you go on the number line, the smaller that number gets. And the more right you move on the number line, the bigger the number gets. Absolute value is a number's distance from 0. So oftentimes, I always just call absolute value numbers without the signs, because it's basically the spaces between that number and 0. So again, 3 is 3 spaces from 0. Negative 3 is also 3 spaces from 0. So the absolute value of 3 and the absolute value of negative 3 are both 3 because they're both that many spaces from 0. So it's almost like you're looking at the number without the sign. The symbol for absolute value are 2 lines with the number in the middle. So if I was going to ask you what is the absolute value of negative 3, I would write it that way, and then you would just answer it as a 3. All right, so let's look at the 3 essential questions that we're going to be learning today. The first question, is define what is an integer and draw an integer number line. Okay, so remember integers are all of our whole numbers, positive and negative, and it includes 0. Compare and contrast how to add integers with the same sign with how to add integers with opposite signs. And then the third one is explain how you can subtract 2 integers and provide 2 different examples. Okay, let's go over what an integer is. Integers are rational numbers that include whole numbers that are positive and negative, and also 0, which has no sign. So all of these examples here are all integers. Now, if you have something like a negative 1/2, that's technically not an integer, okay? Because integers are whole numbers. Now, so you can have negative numbers that are not considered integers, okay? Let me erase that so that we can read. Okay, you can use double-sided math chips to help you learn how to add integers. They usually look like this. One side is one color and the other side's another color. I often see them with yellow and red, but they don't have to be yellow and red. I've seen gray and black before. We call them math chips. And usually one side will represent the number in its negative form, and the other side, or the other color, will represent the number in its positive form. Okay, so I'm going to show you how to add integers using the opposites, okay? You can model any integer addition problem using opposites and math chips that have at least 2 colors, okay? So opposites are numbers that are the same, but one is positive and one is negative. So an example here is a positive 1 and a negative 1. So I have made the positive 1 be represented by the yellow math chip and the negative 1 be represented by the red math chip. Adding 2 opposite numbers together always cancel each other out to make a 0. Okay, and this is important when you're using these math chips, is to understand that opposite numbers cancel each other out. So here's examples of opposites. We have a negative 3 plus a positive 3 equals a 0. Positive 15 plus negative 15 equals a 0. And notice I put parentheses around this. The reason I did that is most of the time, not always, but most of the time, you don't want to write 2 operations side by side. So this is a plus and then a negative, and you typically just put this parentheses here just to separate the plus and the minus so that you're not having 2, symbols like that right next to each other. Negative 9 plus positive 9 equals 0, and then positive 7 plus negative 7 equals 0. Okay, so let's look at this example of using these math chips. The first example is negative 3 plus positive 5. So the first thing I'm going to do is put down 3 red chips, because red means negative 1. And to get negative 3, I need to get 3 of those chips. So I'm going to put those 3 chips down first. Then I'm going to take the positive 5 in my problem and list those right under the 3 red chips. So the positive chips are yellow, and I'm going to write those right underneath where I placed the red chips. Now I'm going to cancel out any of my opposites. So I have these first 3 that are canceled, and since a positive 1 and a negative 1 makes a 0, all of these are essentially just a 0. So what you're left with are 2 yellow chips. So the answer is a positive 2. Okay, here is adding integers using a number line. Okay, so you can model any integer problem using an integer number line. I'm going to show you how this works. The more left you go on the number line, the more negative it is, and the more right you go on the number line, the more positive it is. So right here we have, we always start at the 0 part, right in the middle, and our first number is negative 4. So we moved from the 0 to the -4. That's the first thing we need to do. And then once we're here, then we add the +8. So now that we're at the 4, we're going to start here and move 8 spaces in the positive direction. Okay, so the first time we went in the negative direction. Now we're starting from here and moving 8 spaces in the positive direction. And where I end up is at the +4. So that's why the answer here in green is +4, because that's where I ended up after adding this +8 to this -4. Okay, let's try it again with the second one. We have a -3 here. So again, we're starting at 0 and we're going to go down to the negative side 3 spaces. Okay, so we're going to stop right here. And then we're going to add another -2. So instead of going right this time, we're going to go left again. And we're going to end up here at the -5. So our answer here is -5. Okay, now we have a challenge. We're going to try to do this one. This one has 4 different terms. Each one of these lines is considered each one of these numbers is considered a term. Terms are separated by the operations in the problem. So since the first one is a positive number, I'm going to change my pen color to a blue. And I'm going to start at 0 and I'm going to go 2 spaces to the right. Okay. I'm going to stop right here on the +2. So this was +2. Okay. Now I'm going to switch to my red because I want to do the negative parts. Now again, once you move, you're going to stay right there. You're not going to move back to 0. You're just going to stay here. But now we need to move back -1. So I'm going to start here, move back a -1, and I'm going to stop right in line with this -1 here. So I'm going to write a -1 here. Okay. And again, I'm now here at the -1. And I'm going to have to go another -6. So since I'm adding a -6, I need to go 6 more spaces to the left. So if I go from the +1 here where I'm located now and go 1, 2, 3, 4, 5, 6, I'm going to end up, whoops, I'm kind of going over my 10 here. I'm going to end up right here on this 5. Okay, I'm going to put a dot there so you can see what I'm looking at. So I end up at this -5. Even though I went back -6 spaces, my line is not straight. I apologize about that. It's hard to draw with a mouse, but I went back 6 spaces, but because I was at the 1 and not the 0 to start with, I ended up at -5. So that's where I'm located currently, but I have one more term to add, and that is a +10. So I'm going to go and get my +10 blue out. I'm going to start here at the -5, and this time I'm going to go all the way 10 spaces to the right. So if I'm at -5 and I go 10 spaces to the right, I'm going to end up at a +5. Okay, so I got to go +10. And so +5 would be my final answer because that is where I end up after traveling all of these terms up and down our number line. All right, so integer adding rule and the song. Now, the adding rule is one of the most challenging rules to remember. So they have created a song that that helps you to remember it. So let's review the rule first, and then I'll teach you the song. Okay, to add 2 integers that have the same sign, add them and keep the sign that's already there. So if both numbers are positive, you're going to get a positive answer. Now this is for addition. When you're doing operations with integers, the operation is important. So, you know, the way you treat integers when you're adding is different than the way you treat them when they're subtraction and multiply and divide and so forth. So negative plus a negative is also a negative answer. So you're just adding the numbers like you normally would. 2 plus 5 is 7, and so that would be a +7. -2 plus -5, that should be a negative there, that's a typo, is -7. Okay. Change that to a red real quick. All right, just so that we're clear on that, that's going to be a -5. Okay, to add two integers that have different signs, okay? So same signs, you just add and keep the sign. Two integers that have different signs, this is where it gets a little complex. We don't add them. We find the difference, okay? And what I mean by find the difference is don't pay attention to the signs and just subtract the smaller one from the bigger one, okay? The absolute values of those numbers, okay? You're just going to, like if it's a positive 5 and a negative 2, you're just going to subtract 5 minus 2 to get a 3. And then same with a positive 2 and a negative 5, you're just going to subtract 5 minus 2 to get a 3. You're just subtracting the absolute values, so don't think about the signs just yet, okay? Once you find the difference, then you look at your numbers. The biggest absolute value or the largest absolute value is the sign that you're going to keep, okay? So in my first example, the positive number was bigger than the negative number. This positive 5, the absolute value, is bigger than this 2 here. So because of that, my answer is going to be positive, okay? On the second example, the positive 2 here is smaller than the negative, okay? So again, positive 2 is a larger number than negative 5. We know this because, you know, positive is definitely bigger than negative. But remember, we're comparing the absolute values. We're not taking this negative into account. We're just looking at the actual number without the sign. And definitely 5 is bigger than 2. So since the negative absolute value is bigger, we're going to keep the negative in our answer. Okay, this is why it gets a little confusing because the answer could be positive or negative based on which of the terms has the largest absolute value. Now let's look at the song. The integer song goes like this, and it's to the tune of that song, that old song, Row, Row, Row Your Boat. Okay, so it goes, same signs add and keep, different signs subtract. Keep the sign of the larger number, then you'll be exact, okay? Sometimes they say keep the sign of the bigger number, then you'll be exact. Now, this can be misleading because, again, negative 5 is technically not larger than 2. So really the song should say keep the sign of the largest absolute value, okay? Keep the song of the largest absolute value. I'll just put ab-val. Okay, but we're not going to put that in the song, but technically that would be more accurate or more precise. So let's do that one more time. Same signs add and keep, different signs subtract. Keep the sign of the largest number, then you'll be exact. Very good. Okay, hopefully you tried that on your own. And again, when it says largest number, it means the largest absolute value or the distance from 0, not the actual largest number, okay? So this takes some getting used to, but the song really does help. And remember, the song is just for adding integers, okay? If they have the same signs, add them and keep whatever signs there. But if they have different signs, subtract or find the difference, then keep the sign of whichever largest absolute value, whatever the sign is on the largest absolute value, okay? All right, so now subtracting integers is really just a rule to change every subtraction problem into an addition problem. So that addition rule, the one we just looked at here, we're going to use this again with our subtraction problems, okay? And so basically the rule for subtraction is to change our subtraction problems into addition problems, okay? So to subtract integers, it means to add the opposite sign of the number being subtracted, or the second number, okay? So we use what we call KCC, or keep, change, change, okay? What that rule is stating is that you're going to keep the first term in your problem, okay? Then you're going to change the subtraction to addition, and then you're going to change the second term to its opposite sign, okay? So keep, change, change. You're changing it because you're wanting to change it to add the opposite sign of that second number, okay? So subtracting a number is the same as adding the opposite sign of that number being subtracted. So what a lot of people do is just go down your subtractions and go keep, change, change, keep, change, change, keep, change, change. Keep, change, change. You see how I'm just turning all of them into addition and then changing the symbols to its opposite. Like again, I'm changing the negatives to positive here. So again, you can just go down and change, keep, change, change, keep, change, change, turn them all into addition problems. Then you can revert back to this addition rule and solve the addition problems, okay? Okay, here's an example of a number line using the subtraction. So here we have 5 minus 2. So we started at 5, and then we went into the negative direction 2, and we ended up at 3. Okay, negative 5 minus 2, we started at negative 5, and we subtracted 2, so we went into the negative direction again, 2, and we ended up at negative 7. And then, oops, excuse me. And then the last one, negative 5 minus negative 2, we started at, let me move my face here. You can't see that, but I can see it. We started at 5 here. We went to, take that back. We start at negative 5. And then when we do our keep, change, change, that means we need to add 2, and we end up at a positive 3. So again, this one, if I did keep, change, change, that would be negative 5 and negative 2, which gives us a negative 7. And if I do keep, change, change here, that would be 5 plus negative 2, which is a positive 3. Okay, so here's just a little graphic on the adding and subtracting integer rule, and this is just for review before we try to do some of these problems on our own. So let's review. To add integers, find the absolute value of each number, find the difference between the two numbers. 8 minus 5 is 3. Then check which absolute value is larger, and whichever one has the larger absolute value, you're going to keep the sign on that number. So in this case, the 8 or the negative 8 was the larger absolute value. So our answer after subtracting 8 minus 5 is going to be negative 3 instead of positive 3 because the 8 had the larger absolute value. Okay, that's adding integers with different signs. And then we have subtracting integers. Change your subtraction sign to an addition. Okay, and then change the number after it to its opposite. So remember that keep, change, change rule for subtracting. You're basically changing your subtraction problems into addition, and then solve by using the adding integers method. So the same signs we add and keep. So negative 8 plus negative 5 gives us a negative 13. And of course, keep, change, change is the subtraction shortcut method for changing your subtraction problems into addition problems. And of course, the song, same signs, add and keep, different signs, subtract. Keep the sign of the larger number, then you'll be exact. That will help us remember the addition rule. All right, let's try to grow a blossom. So first, model and solve the following integer addition problems using math chips. Now, if you don't have math chips, you can substitute by drawing circles. So I've given you some examples here. You can make a positive circle look like this, and then a negative circle look like that. So you can still use math chips in a way by drawing them yourself in this way. So just pretend that's the red one there and that one there, the yellow. Oh, I'm sorry, the positive was yellow. So the positive one, just pretend that one's yellow and this one's red, if that helps you. Okay, I'm going to pause and just go ahead and count. 1, 2. Oh, I didn't put the problem up there. Let me put the problem up there for you. Okay, it's 11 plus negative 5. So let me pause and let you try to do that one on your own. 1, 2, 3. Okay, here's an example of chips being used to solve this addition problem, this integer addition problem. So we have 11 positive chips here, okay? And then we added negative chips to that, which is negative 5 chips here, okay, the ones in red. And then I canceled out all of the opposites. So we have a positive, negative, cancel out, positive, negative, cancel out, positive, negative, cancel out, all the way. And we are left with 6 positive chips. So that means our answer should be 6. So hopefully you got that and you were able to do that by showing the modeling, by showing the chips. Okay, let's try a different one. Model and solve the following integer addition problems. This time try to do it using a number line. Okay, so let me show you the problem. We have 3 of them. We have a 6 plus 3, a negative 6 plus 3, and then a negative 6 plus a negative 3. So let's go ahead and try to do that one. Let's try to do it using a number line. 1, 2, 3. All right, so here we have 3 number lines. The first one is we started at 0 and we went to the 6 first because 6 is a positive number. And then we went 3 more in the positive direction and we ended up with a 9. So 6 plus 3 is a 9. There's our number line that shows that addition problem. Now we have a negative 6 plus a 3. So again, starting at 0, we go all the way to negative 6. And then after we're at negative 6, we go in the positive direction, 1, 2, 3. And where we end up is the negative 3 spot. So our answer there would be a negative 3. And then the number line at the bottom, we have a negative 6 plus a negative 3. So we start off at 0, we go to negative 6. And then we have to add an additional negative 3. So we need to move in the negative direction 3 more times. And we end up at a negative 9. All right, let's try to grow a third blossom. Solve the following integer addition problem and using the rule. And this time, try to remember the song because that might help you remember how to do this one. Okay, so we have 3 here, negative 7 plus negative 10. Negative 2 plus 16, and then 28 plus negative 3. So go ahead and try to remember the song and try to do those addition problems using the rule instead of a number line or chips. 1, 2, 3. All right, so here we go. Our answers here should be negative 17 because we are adding negative 7 plus negative 10. And negative 7 plus negative 10, they have the same sign. So we're going to just add them and keep that same sign. Here we have a negative 2 and a positive 16. And so the difference there, since the signs are different, we take the difference. The difference there is a 14. And we keep the positive sign because the 16 absolute value is bigger than the 2. Okay. 28 plus negative 3, again, different signs, so we subtract them and end up with a 25. And again, we kept the positive sign on this one because the absolute value of 28 is greater than the absolute value of negative 3. All right, our fourth math blossom, solve the following integer subtraction problems using the subtraction rule. Okay, so here's some more problems. Negative 7 minus negative 10. Negative 2 minus 16, and 28 minus negative 3. So try to solve those using the subtraction rule. 1, 2, 3. Alrighty, now we've got negative 7 minus negative 10. So if I did a keep, change, that would change to a plus, and that would change to a positive. So again, when we have a positive being added to a negative, we need to subtract them and keep the sign of the larger absolute value, which in this case would be the positive 10. So our answer is positive 3. Again, we need to keep, change because that's our rule for subtracting. So keep the first term, change it to a plus, and change the positive 16 to a negative 16. Here we have a negative being added to a negative. So same signs, we just add and keep the sign, and so we end up with a negative 18. Again, we keep, change, and this time we end up with a positive 28 being added to a positive 3. So our answer is going to end up being a positive 31. All right, so let's pause and try to answer the essential questions. Define what is an integer and draw an integer number line. So we'll go ahead and try to do that, and I will wait about 3 counts. Okay, hopefully you unpaused it and took your time. An integer is a whole number that is either positive or negative, or it is 0, which has no sign. Here's an example of a number line. It's basically a line with arrows at each end. The center is usually the 0, and on the right side of the 0 are the positive integers, 1, 2, 3, 4. The left side of the number line is the negative integers, -1, -2, -3, -4. So if your number line looks similar to this, then you did it correctly. All right, let's look at this second pause and answer the essential question. Compare and contrast how to add integers with the same sign with how to add integers with opposite signs. Okay, so I'm going to ask you to pause and try to answer that one on your own. All right, so the answer, to add integers with the same signs, just add them and keep the sign that you already have. So just like the song says, same signs, add and keep, that's what they mean. Then to add integers with different signs, subtract them or find the difference and keep the sign of the number that has the largest absolute value. All right, our third and final pause and answer the essential question is explain how you can subtract two integers and provide two different examples. So go ahead and pause and try to answer this one. All right, so to subtract two integers, you need to add the opposite of the number you are subtracting. So in order to do that, we use the keep, change method, which adding the opposite means we keep the first number, change the subtraction symbol to add, and then change the second number to its opposite sign. Here are a couple of examples. 10 minus -2, we would keep change that problem and turn it into 10 plus +2. We're adding the opposite. Instead of subtracting a -2, we're adding a +2, which gives us a 12. -14 minus -4, again, keep change, -4 plus +4, we're adding two different signs. So we take the difference, which is a 10, and we keep the negative this time because the 14 has the larger absolute value and the 14 is negative. All right, so our vocabulary today, let's go ahead and do our review. This really large horned cow here, I don't know if that's a cow or a bull, I'm not really sure, but it just looks adorable in those flowers. But it's going to help us with these. So what is an integer? An integer is all of our whole numbers, positive and negative, including 0, which is neither positive or negative. Positive signs are usually a plus or there's no sign at all. Most of the time you'll see it with no sign at all. Negative sign is a minus that's directly in front of the number. That indicates that we have a negative symbol. Opposites are two of the same numbers but have different signs. So like -8 and +8 would be opposite numbers. Opposite numbers can be added together. Those are called additive inverses. When opposites are added together, they create a 0. They cancel each other out. Number lines are how we can learn how to use integers. To the right of a 0 on a number line is your positive numbers, and to the left of the 0 on your number line is the negative numbers. Absolute values are the distance a number is away from 0. Absolute values are never positive or negative. Or actually, they're technically all positive, I should say, but the sign is not taken into consideration. It's just the distance from 0. All right, great work, everybody, and a bouquet of math blossoms have opened up in your mind. So to further improve your math language skills, remember to practice by doing your classwork and your homework. Study 10 minutes at least each day. Ask for help if you need it, and then learn from any mistakes that you make. And never give up, always try. Persistence is something that math definitely teaches us. I've literally spent probably 5 or 6 hours on specific math problems when I was taking, more accelerated math courses in college. So yeah, it does train you to be more persistent and more patient. All right, so I'm Miss G, and I wanted to thank you for watching this Math Blossoms video. This is how to add and subtract integers. So the next video you should probably watch is how to multiply and divide integers. So that's the next one in this series. So it's now time for me to say, it was lovely teaching you math today. Bye.